welcome back. So, we've covered many different topologies using only Q-SYS equipment, but we know in the practical world, all sorts of things get integrated to Q-SYS. In fact, that openness is probably the exact reason you use it. We'll start with Dante integration, as it is a common use case. The most basic use case is a Q-SYS system using LAN A for Q-SYS peripherals and QLAN, and a dedicated network for the CDN64 or Q-SYS Dante card. As we discussed before, we use what's called the Differentiated Services Code Point, DSCP, to prioritize traffic in the switches. Q-SYS adds a DSCP value to PTP-v2 and QLAN packets. Audinate-based devices such as the CDN64 do the same thing with PTP-v1 and Dante. These values are then associated with priorities in the infrastructure called QoS Queues. In this case, the QLAN switch would be configured according to QLAN guidelines. Values 46, 34, and 26 would be prioritized in that order, as those are the DSCP values for PTP-v2, QLAN audio, and QLAN video, respectively. The Dante switch would be configured with the values recommended by Audinate. They use 56 for PTP-v1, 46 for audio packets, and 8 as a reserved value for some special functionality. If we look at the Q-SYS design properties under the File menu in Q-SYS Designer, we see that Q-SYS has QoS presets that can remap these DSCP values. In this case, we'd use the default QLAN values. This leads us to the next use case. We can converge Dante and QLAN onto the same network as shown in this diagram. To make QoS setup simpler, we choose the Audinate QoS preset in the design file, which allows us to use the Audinate DSCP values in the switch setup. Now, of course, this is very often the case when software-based Dante is used in conjunction with Q-SYS peripherals in a Core 110F system. Software-based Dante will always use the Audinate DSCP values regardless of the QoS preset chosen. We're only remapping QLAN values to match. If we'd like a separate network for software-based Dante, that is still possible. The Q-SYS Design Properties dialog allows us to choose the network interface used by Dante using the interface parameter. Remember, LAN A is always the primary QLAN network. That is not selectable. And for our final feats, consider this masterpiece: redundant QLAN and Dante networks on the same infrastructures. In this case, we'd use the Audinate QoS presets and assign the software Dante interface to both, as shown. Now, another audio transport commonly integrated into Q-SYS is AES67, which has been supported since Q-SYS Designer version 6.0. Like software-based Dante, the interface used by the AES67 transport can be selected in software. AES67 can be integrated with QLAN using LAN A as shown in the top diagram, or separated onto LAN B as shown in the bottom diagram. Rather than being a global design setting like software-based Dante, the interface selection for AES67 transmitters and receivers is in the control dialog for the block itself. There's an auto selection, but best practice is to select the appropriate interface manually. Remember, AES67 makes use of multicast audio streams exclusively. As many AES67 endpoints are also 100 megabyte per second devices, you'll want to make sure to enable IGMP snooping and filtering to protect them from saturation. A good rule of thumb is to enable IGMP features when you have more than 5 AES67 streams on the network. Now there's the matter of QoS and AES67 integration. Let's say I have an AES67 endpoint and QLAN on the same network. How should I prioritize the traffic? As we discussed before, we use what's called the Differentiated Services Code Point, DSCP, to prioritize traffic in the switches. Q-SYS adds a DSCP value to PTP-v2 and QLAN packets. The switch is then configured to recognize those markings and make them a higher priority than others. The AES67 standard suggests that PTP-v2 and audio packets carry the same DSCP markings as QLAN. Those are 46 and 34, respectively. The good news then is if you're integrating with an AES67 device that follows the standard, you can follow the Q-SYS network setup guidelines and you're done. That's not the most realistic case, however, as most AES67 integrations are actually done using Audinate chipsets that do and do not follow the AES67 standard under certain circumstances. DSCP markings for each packet type in Audinate-based devices depends on the product being used and the Dante firmware version. Here's how it works. All Audinate Ultimo devices, which are typically small devices up to 4 audio channels, use the same DSCP values as Dante when placed in AES67 mode. This includes most current Aterotech by QSC wall plates. Higher channel count Audinate devices based on the Brooklyn 2 or Broadway chipsets vary depending on the firmware version of the device. Devices running Dante firmware version 4.1 and below carry Audinate DSCP values, while those at 4.2 and above carry the AES67 standard values. Another thing to remember is that AES67 makes use of PTP v2, while Audinate devices must still participate in a PTP v1 domain, even if in AES67 mode. This makes configuring QoS a little trickier, so let's first make sure we know how to get the information we need to understand our particular use case. To determine the Audinate firmware version running on a given device, we can use Dante Controller software, which can be downloaded from the Audinate website. If we start up Dante Controller and navigate to the Device Info tab, we see each device and the Dante version it's running. Keep in mind that the manufacturer's firmware version often doesn't match this version, so you want to make sure you're looking here. In this case, we see a device running 4.1.3.5. We know that it will use Audinate DSCP values when in AES67 mode. This endpoint is running 4.2.0.28. Now, we need to know what device type it is. The device type can be found by double-clicking on the device in that view. Navigates to the Status tab, and the device type can be found here. Again, if this is Broadway or Brooklyn 2 and the firmware version was 4.2 or higher, then you know the DSCP values for AES67 mode will be as shown. As they said at the end of every G.I. Joe cartoon, knowing is half the battle. Now that we know what devices we have and the DSCP values they'll carry, we have to decide how to set up the Q-SYS QoS presets and the switch QoS queues. There are 3 major cases we'll have, so let's explore each one. The first case is where we have Q-SYS and all or some combination of Ultimo-based devices or older firmware Brooklyn 2 and Broadway devices. All those devices will carry the Audinate DSCP values. Here we use the Audinate QoS presets in Q-SYS Designer and set up our switches with the Audinate queuing settings. The next case is where we have Q-SYS integrated to all Brooklyn 2 or Broadway devices. As you can see, this is a little more complex. We have different DSCP markings for the 2 PTP standards. The QoS setup in the infrastructure may depend on the abilities of the switch. If the switch allows multiple DSCP values to be placed in the same QoS queue, then we'd like PTP v1 and 2 to be the same priority. The setup would be exactly as shown in the table. If the switch does not allow multiple DSCP values to be placed in the same queue, then of course each value would need to be placed into its own queue. This of course requires one more queue, but that should be fine. It doesn't matter which of PTP v2 and v1 is placed in the highest queue, as long as they're both prioritized above all other network traffic. Since 56, 46, and 34 are all used in this case, the QoS preset for Q-SYS shouldn't be a problem in either the QLAN or Audinate setting. We'd recommend QLAN so that all PTP v2 traffic carries the same markings. We have the same concerns if we have a mix of Ultimo and newer firmware Brooklyn 2 or Broadway devices. We'd set things up exactly as the previous case. Note that these last 2 cases can be simplified if the interface to Q-SYS can use the CDN64 or software-based Dante. If you can have all the new firmware Brooklyn 2 and Broadway devices use Dante, then all the other devices will use Audinate values. Use the Audinate QoS preset in Q-SYS and you're set. This concludes our look at common topologies and use cases. Now we'll turn our attention to network troubleshooting.